Ben, I'm going to let you introduce yourself. So very quickly, welcome to our Govies. This is a special event we have this month. We usually have our event the third Thursday of the month, which is actually this coming Thursday. So we have a special presentation given by Ben Rogers and Travis Hoppe. Travis, I never know how to say your last name.
I feel like you should by now. No, it's Hoppe.
I know.
Thanks, Wendy.
Yeah, and so I'm going to let them introduce themselves, and they're going to give us a talk on Chat GPT.
And Wendy, I'm going to jump in and remind folks that they should keep themselves muted while Travis and Ben are presenting. I anticipate that they could put questions in the chat as we're going, and that you will monitor that or raise their hand if it's appropriate. But if folks could be muted, that will help the quality of the recording.
Thank you very, very much, Donna, because I did forget that. So, all right. Well, Ben, I'll let you take it away.
Awesome. Amazing. Thank you, Wendy. It's an honor and a pleasure to be here speaking for you all. Today, Travis and I are talking about Chat GPT. I'm sure you've heard of it, but this is a first look at the utility and risks of large language models as a whole for US agencies. This presentation has been given multiple times by Travis and I. So if you have seen it at one of our other presentations, there's some slight edits to it, but mostly it's covering the same content. I myself am a data scientist with the Division of Research and Methodology at NCHS, and Travis is the Associate Director of Data Science and Analytics at NCHS. So going forward for our agenda for this presentation, starting off, what is ChatGPT? Next, we'll go over some examples, a couple of different fun frame stories so you can see how it can work and really the power of ChatGPT. After some examples, once you've started to see some of the different output, we'll talk about the technical background about large language models and reinforcement learning from human feedback. And at the end, we'll talk about risks and biases and some current NCHS recommendations. Just to let everyone know, Travis and I are both part of a Tiger team that's being set up regarding recommendations for large language models at NCHS. Travis is actually the lead of that team, and hopefully we'll have some research, some actual recommendations published in the near future, which I'm sure Travis will talk about more during the guidance at the end. So let's go ahead and get started with what is ChatGPT? That is a great question. ChatGPT is a conversational AI using an autoregressive large language model trained using reinforcement learning from human feedback by OpenAI. So it has kind of those two different parts. The main engine is GPT-3 or Generative Pre-trained Transformer 3.5. There is GPT-4 that also can be used now, but when we created this, it was only GPT 3.5 available. And then the reinforcement learning from human feedback, which trains it, but that's a lot of text. That's a lot of just, there's a lot there. Why don't we ask ChatGPT, what is ChatGPT according to ChatGPT? And you can ask it to just dumb it down a little bit for you. So you can say it's a little robot friend who loves to talk, and it's really good at talking because it's using something called conversational AI. So which is just a fun little thing you can use ChatGPT for. But now you might be asking yourself, what isn't ChatGPT? Well, it's not a sentient life force chained to a computer. It's not the automation of every job ever to exist or the sign of the new age of robotic oppression. For example, this tweet is rather infamous. It's by a data scientist at NVIDIA named Bojan Tungs. He was meaning this totally sarcastically. There's a lot more to ChatGPT than just an HTML web page with a simple input box, which we'll talk about a little bit more. So you may be saying to yourself, Ben, cool, I've seen this all over the news. Why does this matter? Like I've heard of ChatGPT. Why should I care about it? It's because it's really good at automating or assisting in tasks that previously needed human intervention. And it's so good that Microsoft invested $10 billion into OpenAI, and that was not enough to actually buy ChatGPT, the model. That's just for an investment from Microsoft. And large language models as the whole, outside of just ChatGPT, are being integrated into so many different products. Teams Pro, you may have heard about. Google uses our large language model. All the different search engines now, Office and Windows have had rumors of having different aspects integrated in, and there are other ChatGPT competitors coming. So this is just a ChatGPT presentation, but there are going to be others out there. Google with Bard actually just had an interview on 60 Minutes you might have seen this past weekend, but Anthropic AI with Claude just had their newest version released, I believe, today or yesterday, and Microsoft with Sydney is also very popular. So let's talk about some common use cases that you may or may not have seen. Upscaling or downscaling language, as we just saw, that is a great use for ChatGPT. Creative generation is something that I love to use it for. I love playing the game Dungeons and Dragons, and it's great to just say, hey, create this little scenario for me. It's amazing at that. And it's a phenomenal programming assistant. The phrase I use when I talk to people about this is it's like having a senior developer you can ask any question to at any time, because I can't just send whatever questions I have to Travis. He's got another job. I can't just ask him questions all the time, and I can ask ChatGPT questions all the time. So GPT-4 was released recently, and here's some comparisons that came from the paper from GPT-4 about how good it is on different exams. And this shows how rapidly language models are growing. You can see that GPT 3.5, like it did good on some of these, but GPT-4 did great. Like on the bar exam, jumping from the 10th percentile to the 90th percentile, that's crazy. Just in a couple of months of just training, it's phenomenal. So it's always important when we're talking about these different models to talk about the training data for it. For ChatGPT, it is trained on just a mountain of information. We don't know for sure what exactly is trained from. OpenAI has refused and will continue to refuse to say what exactly the data is. But there's certain things we can say for certain things we can assume, and then some of this will be speculative. There was a disclaimer at the start that this is opinions by myself and Travis. These are opinions by myself and Travis. This is not a stance taken by any agency for anything that I will say here. So there's a couple of different data sets with a large amount of information from the internet. For example, Stack Overflow is a site that has this little chat board you can go and you can put in any different question you have. Oh, I have this issue with coding. What can you help me solve it? And people across the globe can help you solve your coding problem. And ChatGPT was trained on almost all of Stack Overflow. It's trained on all of Wikipedia, most likely all of the publicly accessible GitHub accounts. So all that code there, any of your different, any different federal document that's put out into the public domain, it most certainly has been trained on, whether that's patents, grants, publications, clinical trials, law dockets, all of that has probably been trained on. And it actually uses the output that ChatGPT generates to train itself. That's part of that reinforcement learning process. And then kind of the speculative is that there might be some contractors OpenAI have hired to actually help get better code output. And speculative, they might have gotten licenses or they might not have gotten licenses to different copyrighted material, whether that's different books available or not available that are available on the internet. We don't know what their licenses are. OpenAI has refused to say what licenses are. We do know that there's copyrighted material that ChatGPT can generate at some point. So I'm going to go ahead and pass it over now to Travis to talk a little bit about some current NCHS guidance.
Thanks, Ben. I will say that we, as a statistical agency at NCHS, recognize that there isn't a lot of guidance for us on what to do from either HHS, from our parent agency, CDC, or even from the federal government writ large. There are these things out there. OSTP has put out guidance for ethical use of AI, but they really don't cover things like Chat GPT. So the advice that we kind of put together for our staff, and I think it's broadly accessible, not just for Chat GPT, but for any kind of web-based portal which you're entering information, is just to remember, number one, that they're public portals. Unless you understand and have a contract with the company, with the terms of service, you put in uncleared manuscripts, you could run into problems. You could run into problems from documents that shouldn't be out there. You can run into IP problems. You could run into releasing sensitive data that could end up in a training data set. So really, if you're going to use it, know that they're public portals. There's some nuances with that with the API that I'll put in the chat when I'm done with this slide. But also, and if we get time to dive into this, large language models are trained off of text on the internet. They're full of bias. And these biases exist in our human discourse, and the large language models will reproduce that. And so it doesn't mean they're inherently bad, but it does mean they can cause harm if you don't recognize that. So we ask staff to recognize that when you're going to use these things, to try to understand where the harms could come from and see if they fit with the use cases. There's no factual guarantee about the outputs. This is true about the internet in general, but ChatGPT generally does not like to cite its sources. So if you ask it to make things up, it will happily do so. And sometimes when you ask it to do something for you and you don't think it's asking it to make it up, it will also make it up. It has limited knowledge of the events that it was trained off of. I think the final training for the main model was finished in 2021, and there's been some fine tuning adjustments since then. I think GPT-4 has a little bit more modern knowledge, but basically when the model was done training, that's the end of its knowledge. And so using it to kind of predict or synthesize current events can be problematic if you don't know that the model itself, it has a limited time frame for its background. So Ben, I think I will turn it back to you to continue the examples.
Awesome. Thanks, Travis. And one of the things that Travis mentioned there, but according to OpenAI's actual terms of use, any input that you put into the ChatGPT UI through the website, they will use that. They consider that as their data that they will use. So this is directly taken from their terms of service. This is one of the reasons why you might have seen in the past that ChatGPT was banned by Italy. It's because of this kind of gray area. So, but now let's go ahead and get out of that kind of little policy talk. Let's talk about some fun examples. For example, let's talk about my favorite athlete, Tom Brady. So if you don't know who Tom Brady is, he's a retired NFL quarterback. He's exceptionally well known. Some may refer to him as the GOAT, which he is, the greatest of all time. He played for 23 years on 2 different teams in the NFL. He's a 7-time Super Bowl champion, but important thing to know, he has a 64% career pass completion. So when he throws a ball to one of his players, that ball is caught 64% of the time. A little bit more background. This talk was originally given for statisticians at NCHS. So we only explained who Tom Brady was. We didn't explain what kurtosis is, but we've added since then some background on what kurtosis is. It's a measure of the tailedness of the distribution. It's the 4th moment of that distribution. So things like average, variance, skewness. Kurtosis is the 4th. So it means how much do observations fall into the tails of a distribution or the likelihood it's going to produce outliers. So you may be saying, hey, Ben, like Tom Brady's retired. I really miss him. I miss watching him on TV. What if I just did, a little project using SAS on Tom Brady's career where I just wanted to see like how his pass completion, how even was it over his career? I want to see how likely he was to have outliers for his pass completion. Well, if you ask ChatGPT, it'll give you a breakdown. It'll create code that you can copy and then paste into your IDE here of SAS. It does that for pretty much all the different languages, and it can explain what that code does. Going off of that is, oh, hey, well, I'd like to see the output of this code. Can you show me the output? ChatGPT created the output there. It created some numbers. And if you look at the mean, 62.8%, that's not far off from the true. Like it had an idea of what Tom Brady's career completion percentage was, and it was so close to it. And it gives a little example of how it, of what that means. And so you say, hey, this is great. Yeah, show me some potential output. Or can you please explain to me what this output is? It can give you that explanation, which is phenomenal. I do apologize that I am going rather fast. We do have a lot of slides. Originally for this talk, it was intended to be over Teams, so you could actually go back and forth, going over different examples based off of what you find most interesting. But unfortunately on Zoom, we don't have the options to do that. So I apologize for all the text that it's a little hard to read on the screen. So all that to say, Ben, it's great. Okay, it can create output in SAS. It can explain to me what that output means. It can explain what kurtosis could mean for Tom Brady's career. Can I use this for another programming language like R? I'm trying to learn R. Can it do that? Yeah, ChatGPT knows R as well. It can generate code that can produce Tom Brady's kurtosis for his career completion percentage and explain how that works. And you may be saying to yourself, okay, this is great. Can it upscale some language for me about this and make it into a potential journal article that I'd like to publish? It can do that. Can it downscale that language to make it so I can explain it to non-Tom Brady fans? It can do that. And, sometimes we like to think outside of work about maybe something else. What if you were trying to experiment, cooking, like somebody who's retired, like Tom Brady? Now he's no longer an NFL athlete. He might want to work on his diet, or he doesn't have to be as strict with his diet. So maybe he wanted to create a candy that was a cross between a Milky Way bar and an Almond Joy, where there are those generic instructions out there. Well, here's some instructions on a cross between a Milky Way and an Almond Joy. And you know what's crazy is you can actually ask ChatGPT as well to create a script of Tom Brady talking about the joys of retirement, featuring him making that candy and talking about how much he likes using ChatGPT. So just some incredible things that ChatGPT can do. So, but going away from some of the fun talks, let's go and talk now instead about drafting disclosure reports for an IP release at FDA. So here, if you ask ChatGPT, one of the beauties of ChatGPT is it can go across so many different areas of just so many different fields. So it knows what a disclosure report for an IP release at the FDA will have, and it can break down those different sections here. So, oh, what's the introduction of a disclosure report for an IP release at FDA? Oh, it's about intellectual property. Here's some different things about it. Oh, it needs to have a purpose. It needs to have an overview. It needs to have some background information. Okay, what's an impact assessment, ChatGPT? Oh, it's a crucial part of the discourse to see what would happen if the intellectual property was released, and here are the different parts of it that are needed. Oh, hey, can you expand on that risk mitigation section of it? Sure, I'd be happy to. Here's some different parts of risk mitigation. Again, I'm sorry, we're going through this rather quickly. It's very hard to read over all the different parts of these texts just because of the number of slides. And we do want to get to a question section that this is going rather quickly. If you've had any fun use cases of ChatGPT, please put them in the chat. I would love to hear them in times that you've seen it as well. But overall, when looking at ChatGPT of how good it is at these different things, you can look at it to see as kind of a sounding board of, oh, how could this policy backfire, or how could this cause harm? It's a sounding board for you can use before you go to others. But just do keep in mind the different policy that Travis mentioned earlier. So for another frame story, here's some potential privacy concerns that we have seen regarding with the use of ChatGPT. So for example, you can ask it to reproduce intellectual property. Given earlier, I did state that ChatGPT may or may not have been trained on this. We don't know, and we probably will never know. You can ask it to generate the first paragraph of different books or different novels. So here it's about Stephen King's book Misery, and it can generate the first paragraph of the novel, where it creates a little thing here. Hey, do you want to ask it to make the next paragraph? It can produce the next paragraph. Oh, do you want to ask it to produce another paragraph? It can do that. It can keep producing different aspects of this. It is important to say this isn't the exact actual full text of it. It is kind of a bit of a summary instead. But the end there, your number one fan, that is a big point of like the opening of the book of Misery is that. So it does follow along the lines of the novel Misery here. And I've also tried this with other novels. For example, the Spanish translation of Percy Jackson, it actually will pull in different sections of the book because that's how it thinks it starts. But something that's more popular like Harry Potter, it gets far more accurate in terms of the first paragraph, second paragraph, and third paragraph. Some more really interesting concerns. It's really good at creating some identities that sound very plausible. So here, this is a potential fictional character who works for the National Center for Health Statistics with a fake email, a fake phone number, fake background, fake position, and some of their interests. So this is all the things that ChatGPT created based off of what it knows from its training data set. But it's pretty good. Like if you were to read this and you didn't know it was fake, you would say, oh, this kind of looks like an introduction for somebody who would be speaking at a session like this. And another one that is very interesting is this idea of spear phishing. So the idea is if you send in an email to somebody that's very friendly, you can get them to send back different information for it, like getting a bunch of damaging information from someone. So here you're creating an email that says, oh, I'm a security engineer at the census. Can you make a very friendly email to the privacy officer at the HHS Office of Security and asking for secure data for testing purposes? So this was a real case. This is a major red flag. We don't want this to happen, of course, but ChatGPT can generate a very convincing sounding email. And I'm going to actually pause here to let you read over for 10 seconds to read over this email and to see how it's very easy to fall for this type of email. Okay, I counted for 10 seconds. If you didn't finish, I do apologize. We do have a lot of slides to get to, and the discussion part of this is always so fascinating at the end that we wanted to move on to that. So this part is actually really, really fascinating. If you wanted to have it ChatGPT create fake content, it can, depending on what type of things you ask. So for example, here, Travis asked ChatGPT, can you generate a set of fake references to an NCHS publication that are super hot takes? So if you've ever heard the phrase hot take, it's an opinion that might not be wrong, or might not be right, I should say, like saying, oh, Tom Brady is not that good of a quarterback. That's a hot take. It's not accepted publicly going on. For saying super hot take, you're going very far away from what's the generally accepted discourse there. So some of these are obviously something that NCHS would never publish before, but ChatGPT could create it in a format where if you saw this just by the structure of the citation, you would think that it was real if you didn't realize, oh, this is something that's being produced that is fake. I did put an asterisk at the top since one of the aspects of ChatGPT is it does have a model that is a bias or a harm detection model is kind of a good way to call it, where OpenAI will look at whatever prompt you send in for the website and it will say, oh, this is not something we should have somebody ask. And we will give back this canned prompt saying, as a large language model from OpenAI, blah, 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 we can't, it's not something we can do. So if you've ever seen that message, it's actually a model that runs with ChatGPT by OpenAI. And so different variations of this text will generate now a output as a warning from OpenAI saying, oh, these are all fake. OpenAI, like large language models, especially ChatGPT, aren't meant to be doing this, but here's the output of it. But this is something ChatGPT can do. So there's a bunch of fun examples there. That was so fun. Let's get into now the boring part of the technical backgrounds that I'm sure we all love. So you may be saying to yourself, oh, great, Ben, you've been talking about large language models. What is a large language model? Well, let's ask ChatGPT. And it's a system that is designed to use human-like language at a very large scale. So it learns statistical distributions of letters, words, and sentences. Large language models have been around for a little bit of time. For example, term frequency, inverse document frequency, TF-IDF, that's been around for a couple of decades. Word2Vec by Google. Google has been around, I believe, now for 10 years. So there have been some models, but really the large language models that we're thinking of, the ones that power ChatGPT, they didn't really become popular until 2017 with the paper Attention is All You Need, where this attention function was added in and created this transformer framework that has exploded in popularity. So this is one of the reasons why there's just been so much growth within the field is this type of model was published in 2017. And then ever since then, people have been using that framework to publish their own models. So BERT in 2018, if anybody's really into data science, you probably were around for that first initial scare of, oh no, large language models are going to take over the world. That first kind of happened in 2018 with BERT and Elmo. But as you can see, there's been a lot of them going on. And a couple of them, one down at the bottom, Bloom, I do want to give a special shout out to, is that there are open source efforts to make these type of models. So it's not just all by FANG or big tech or all those different companies. There are open source collectives making these types of models, but the amount of computing power you need at scale makes these harder to do. Also, Bloomberg has made their own large language model based off of Bloom, which is also a fun little stat there. But the two large language models I have highlighted here are GPT-3 and Instruct GPT, both by OpenAI. They are predecessors to ChatGPT. So GPT-3 is the predecessor to GPT 3.5, that engine that powers, and Instruct GPT was the predecessor in the reinforcement learning and human feedback piece, that training of the ChatGPT model. Both of these actually have some good technical components of it in their papers that were published by OpenAI, compared to ChatGPT, which does not have a published paper, and GPT-4, which OpenAI has explicitly said we will not talk about how we trained this model or any architecture or anything like that with it. So all that to say, breaking into GPT 3.5, the engine behind ChatGPT, one of the ways I like to think about it is it's like the Olympic weightlifter. If you imagine weightlifting as a sport in the Olympics, you have the weightlifter, you have the weightlifter's trainer, and then you have the referee. The weightlifter themselves, that's GPT 3.5 here. So it's an autoaggressive transformer. It generates text based off of previous text that it has generated with it. It has that attention framework that I just discussed. The parameters for it are not currently known. The size is not currently known. So for that, we will be talking about GPT-3, which we kind of do have an idea of what it is, but only OpenAI has GPT-3, but they have released a little bit of information about it. So it is a generalist model. It's not trained to do any specific tasks. You can have large language models that are published that are task specific or language specific. So for example, at NCHS, Travis and I have both worked on the project SANS, which is semi-automated non-response detection for surveys. It's specifically a language model used for open-ended survey responses, and it's to detect non-response with it. So you could run non-response through this language model and says, oh, hey, I don't know, that potentially is a non-response response. You maybe don't want to use that for your study. So it's really focused on one particular task and one particular type of text. A couple others, you have BioGPT, which is trained specifically for biomedical text. And then there are some that are trained specifically for a task, like Pegasus, which is trained just for summarization here. But GPT 3.5 is a generalist model. It's meant to do any task really that a large language model can do and be on any different type of language. So the transformer architecture, this is such a groundbreaking part. I know this might seem a little bit more boring, but it is so important to see. Like, this just came out 6 years ago, and we're at the point now of where we have a large language model who can pass the bar. That is such crazy growth with this. And part of the reason is that attention allows for a model to understand the meaning of words based off of the words around it here. So that attention framework, it only accounts for the text preceding a word. So if you're a left reading language or a right reading language, in this case for English, where we start from the left, go to the right. So we can see all the words before it and understand what that word means based off of those different words. And this is huge because it gives us the context of the words to identify meaning, and it captures a long range linguistic structure, which is was so hard to do before the attention framework was published. So if you're trying to generate, like we did in our examples before, oh, we're generating a disclosure risk report for the FDA, there's a certain structure that needs to follow. Okay, the GPT 3.5 sees that structure and it's generating along that structure. Or if you need to create larger amounts of code, it says, oh, I see that this code is in SAS. I see that this code is R. I'm going to follow that R structure with this. For the autoaggressive, incorporates text into its calculation. So for example, if you were asked, oh, the first person to walk on the moon was, Chat GPT will respond, oh, the first person to walk on the moon was, and then it sees, okay, the first person to walk, well, a lot of people walk. Oh, on the was, okay, it was past tense, moon. Okay, that's the key driving piece of information for this. I'm going to, based off of the word moon, I'm going to generate probabilities for my future words based off of this. So let's talk about Neil Armstrong. Let's talk about NASA. Let's talk about Apollo missions. All those things can appear then if ChatGPT generates a high enough probability for them. So it's easier to follow a language structure, which is great. Follows grammatical structure like lists, which is always really fun. And it gives contextualized information retrieval, which is great. But going back to what I said earlier about how the transformer model just came out 6 years ago, what does it mean for large language models? Since we only have GPT-3, this is 175 billion parameters for GPT-3. GPT 3.5 and GPT-4 are almost certainly larger models. And if you look back to 2017, 2018 on this graph on the right, that scale there, that's not a regular scale, that's a logarithmic scale. This means it's exponential growth in terms of the size of these large language models. And what that means is we did not expect to be where we are now 5 years ago in the past in terms of how good these models are. And it means that very few of the really high powerful ones the really large ones can be run on a single computer. We're at the point now where these models are so powerful and so large, they need to be run on cloud computing structure. And there are very few places that have A, the capabilities to run it, or B, where it's affordable for those organizations to train that type of model. As an example for this, there's a type of GPU out there called the A100, where it has 80 gigabytes of GPU, which is crazy. If you think about your laptop, my laptop is a scientific one from at CDC and it has 4 gigabytes of GPU, and that's our like high-end laptop. So it's 20 times more powerful. A competitor to GPT-3 was trained on 2,000 of those 80 gigabytes GPUs. It's just crazy how much larger everything is with this. And another point I do want to talk about here as well is that we're reaching the point with all these models where the data set that it's trained on is so large, we're getting to the point where it's going longer. It would take you your entire lifetime to read this amount of text, depending on the model, depending on how much of that text is combined together. It's just absolutely crazy. So, but I did mention autoregressive, I did mention transformer. I did want to go over a little bit about how that generation process works. In this case, just a little example, a little bit of a fun example. This is not what Chat GPT generates. This is just an example for us about how an autoregressive transformer could work. It will be showing you the photo of an animal, so everyone has the same reference point. Chat GPT is a text-to-text model. It does not take images as inputs. There are some multimodal models publicly available. GPT-4 is announced to have an image-to-text component, but it's not publicly available yet. This is something that could happen in the future, but this is just for every person here in this meeting to be on the same page to see. So, for example, this is my lovely dog, Sancho. You may be looking at Sancho and you say, okay, here's a dog. Well, how would you describe a dog? When you're thinking about to yourself, when you say, oh, how would I describe my dog or another dog I've seen to somebody else? Is it maybe their fur color? Sancho has some white and black fur. Maybe his fur length, he has a little bit of a longer fur. Maybe it's his head shape. He has that kind of pit bull black head. He's got some really fluffy ears. His tail is really fluffy. He's my pet. He's my dog. That was how I described him at first. Maybe that would be, or he's an animal. He is a dog. Maybe that's how you would describe him first. So all these things as factors can be used, could affect how you'd first describe Sancho. So if I gave you the task, oh, describe Sancho from that picture to me, you would start from one of those key points and move off of that. So for this here, inside the brackets, that's the potential text. Inside the parentheses are the different probabilities for that set of text. Chat GPT and all other autoregressive transformers will generate it 1 word at a time, but for the sake of space, and for the sake of time here, we are doing small little chunks. So giving the starting text to you all, describe my best furry friend, the dog named Sancho. So you would start with, oh, Sancho. Sancho is a good point to start. Let's all get on the same page. Well, what is that point you're most likely to start with? Well, Sancho's a dog. That seems pretty encompassing. We can talk about a lot of other aspects of this. He's not a cat, so that gives being a dog a very high probability. Being a cat, very low probability. So being a dog wins here. It has more probability. Sancho is a dog. Well, what does Sancho have? He has some white and black fur. He has a large head. He has fluffy ears. All of those are valid descriptions of Sancho there and have a pretty high probability compared to each other. And so it's really a question of how would you interpret it? And how would you interpret it based off of all the many years of things that you've seen of dogs? So for here, Sancho has fluffy ears. That's all the compliments that I've gotten for him. So fluffy ears 1. So Sancho is a dog with fluffy ears. And then you saw his little costume. He's guilty. He's guilty of being a good boy. So all those different values and factors can impact the probability of the words generated. And so that's why we talked earlier about that text that was used to train Chat GPT, because that impacts what words are being recommended. And so now going on to the reinforcement learning with human feedback part, GPT 3.5, that's the weightlifter doing all the work. Here's the trainer helping that weightlifter do their best job. So reinforcement learning from human feedback is be saying to yourself, Ben, why? It's because large language models, as Travis mentioned earlier, they can generate unhelpful, biased, toxic, or false responses. It's fundamentally a different task asking what ChatGPT to do versus what you want, what we as users are trying to do. And that's something that OpenAI publicly said in their Instruct GPT paper, is that this is the process of trying to get a large language model and the user on the same page in terms of the output coming out. So we have instructions, we have implicit and explicit expectations. Explicit, we want it to answer to what we are directly asking, but implicitly, we're asking it to generate it in a format we can read. We want it to be helpful, and we want it to not fabricate information. And this is a part that is so hard. We can never assume that ChatGPT is fully correct, as Travis mentioned earlier. So how reinforcement learning from human feedback works. You get your desired output. It starts with some supervised learning off of that. Then there's an actual reward model. So this is the part where I said the trainer, it has an actual model that will say, oh, this is a good output. This is a human readable output. This is a good output here. So when ChatGPT creates that output, it's given a score, and then GPT 3.5 is fine-tuned using that reward model. So it's rewarded for more of those outputs that are human friendly. So you may be asking yourself, Ben, why not do just pure supervised learning? It's because it's dependent on the previous words, like I mentioned before, where the starting word is how the rest of the text is based off of that. And so you lose kind of that signal of why it had value. And it's more expensive as well to do supervised learning at this scale. ChatGPT has over 100 million users. Essentially overnight, it was within a couple of weeks where it had 100 million users. And doing it through this method, they can take all of that input of users putting in inputs, and then you have a little thumbs up feature, and you can say, oh, I like this little input. And then they can train that reward model and continually update. And this can happen recursively, where the model is naturally happening. So going a little bit over that more, I got a little bit ahead of myself, but it's faster updates for everything here with it. So there's been 4 updates at least of ChatGPT since November launch with this training, with this fine tuning, which is how Travis said when he said, oh, there's some information from 2022. It's these updates through reinforcement learning from human feedback that give these different information. So talking a little bit about information retrieval, it does mean that ChatGPT has all the information within its base weights that it's been trained on. It's just helping it. It's that trainers telling ChatGPT, oh, this is how you should get that information, and not this previous way. So if you're a weightlifter and you're lifting your weights wrong, that's harming you, harming the output, or you could just do a better lift, better weightlifting, get more weight out of it. And so that's what reinforcement learning is trying to do. So for my personal value-based judgment, I said this earlier, it's like having a senior developer you can ask a question to at any time, even if it's wrong, which oftentimes when you talk to a senior developer, not Travis in this case, Travis is always correct, but if you talk to another senior developer, it may be wrong, but it is faster to then have that as a new starting point than to spend 20 or 30 minutes combing through the internet trying to find potential answers. So that being said, if you do have access to it, there is a free version and a paid version. The free version is often at capacity because it is very high demands. I personally have a paid version and I love using it, but not endorsing that in any key way. That is my personal opinion, not the opinion of anybody else. Also, that is a disclaimer. So let's go ahead and talk to you about some risks and biases. So it's always important to understand that where bias exists within a model and to understand how can we minimize that harm. And just because bias here exists, that doesn't mean that that bias is harmful. We just need to know that it exists and to be able to look to find it. And so BERT, which I mentioned earlier, was trained on Wikipedia and a bunch of published books. They were far more selective. They selected neutral language in attempting to keep all of this bias away from the model, but it still produced outputs which could contain prejudices, stereotypes, or different attitudes that can be harmful, even just from text that, oh, it's Wikipedia, it's not supposed to have these things. Oh, it's these published books that we vetted all of them, they aren't supposed to have these. They still exist. At this scale, it's impossible not to have biases that just are societal biases present within the models. So when we're mentioning bias, we are talking here about that bias and not statistical bias going forward. So like I mentioned earlier, for information retrieval, all of information is held in ChatGPT's weights. It's based in 2021, a little bit 2022 from that reinforcement learning from human feedback, but in 2021. And as Travis mentioned, source references are not provided since it's generating each word based off of the probability, based off of the previous words given and the input sentence. It's really hard for the model to actually predict, to actually return where it got that information from. And so this is a massive issue when using it to supply facts. So if you asked it for different information, for example, if you asked it, oh, what's the percentage of hypertension or of people in the US who have hypertension, it will just say, oh, according to the CDC. And it will just say CDC as this mythical entity. And you should just, oh yeah, the CDC says it. And not, oh, hey, it came from one of our surveys, the National Health Interview Survey, or it went from another one of our surveys, because based off of what survey you have, you might get a different estimate produced. And some of that nuance can be lost here. So again, we don't know what explicit data ChatGPT was trained on. We have made assumptions, but OpenAI is probably never going to say what data it was published on. And so talking a bit more about that inherent biases, it is essentially impossible to remove all the biases from the text when we're talking at this scale. 500 billion tokens was the size of GPT-3. It's probably far larger for 3.5. It's probably far larger for GPT-4. And it's so much text here. That's 100,000 times the size of Harry Potter, the entire series, not just book one, the entire series. We're talking about true big data here. And it's, again, mentioned even in neutral data sets that you can't curate at this scale to remove that bias. So that's why there's that bias detection model, that referee that I mentioned earlier. And so if it is going to produce that type of harm or an action that somebody may use to cause harm, it'll produce that canned output with it. So that's that referee stepping in. That is only trained by ChatGPT. So as I mentioned earlier, there are ways around it. So that start output, all you have to do is change a couple of words, where if you wanted to have ChatGPT produce super hot takes, you just have to change a couple of words and it can do that. For example, the Tom Brady commercial that I had written, I had to type in like to have it created, because when I say, oh, write a commercial for Tom Brady, that the bias detection model said, oh no, we're not going to impersonate this famous celebrity. I'm going to say, no, I'm going to throw a flag here. And then I said, oh, but it's like Tom Brady now. Then the model, it said, oh, that's great. You're not actually using it for it. Here you go. The ChatGPT can actually generate the responses and they're always there. It's just a question of, can you get around that model? And there's this whole subdomain of people trying to break through that model, that bias. There's a whole movement within a subreddit on ChatGPT about how to break through that model. It's very fascinating how people do. But talking a bit more about this inherent bias, this is some research by Textio. Textio is a company that actually specializes in research related to bias, especially with ChatGPT here. This is a couple of different screenshots of their work. Special shout out to them. As I said, it inherently has all of our societal biases. So for here, when you're giving a description, you're asking, oh, can you create a description for this different job? For example, kindergartner teacher here, and ChatGPT returns something about that different role. 100% of the time, it returns the pronoun she for kindergarten teacher. In the US, we do have far more female kindergartner teachers than male. That is a societal bias that we have. It's not necessarily harmful. It is reflecting that, but it is a bias that is in the case. And same down, not the same, but you can see for across the different job descriptions where some of these biases that we have as a society are showing through here for ChatGPT. And this isn't just also for a position, but also for a descriptor of that position. So something saying, oh, bubbly, ChatGPT was more likely to associate that for someone who's female versus something that's analytical. ChatGPT said, oh, this is male here. So whether or not that's harmful, that is not my place to say. That it is important to say that these biases do exist within these models. So I've been talking a lot. I need some water. Travis, I'll go ahead and pass it back over to you now.
Sure, thanks. Ben, I'm not sure, are there other slides beyond this one that I can use?
No, this is the last one. Yeah.
Okay, so I have a few things that we've actually given this talk probably like 5 or 6 times, and this talk has evolved depending on the audience that we were talking to. But there are some really important things I want to bring up. And there was a slide we had on alignment. And I want to spend a few minutes talking about alignment, and I want to talk a little bit about fake content and some harms that I don't think were mentioned in the previous slides. So, Ben just gave all these examples of what ChatGPT can do and maybe what it can't do. And I think listening to a lot of people, especially like the really smart people in the chat. And I recognize some of you from conferences and everything else. You're experts. We're good at this. And I think sometimes we get stuck saying like, this large language model sucks. It can't do this. It's like incapable of doing this specific task that I've laid out. I think we as a community should really be looking at the exponential growth of large language models and expect that this is the pace that language models will be developing. And so if something isn't possible now, it will be possible, or it may be possible in the future, in the very near future. Which of these tasks, we don't know, but it's rapidly changing. So like working for statistical agencies, or working for federal agencies, I think we should be answering the questions, cool, if language models were even more general, how could they help us? How could they harm us? How could they help us, achieve our mission of the agency? So by kind of getting stuck on saying, oh, it can't do this, I think we kind of missed the point for the larger discussion we should be having about these models. Like absolutely talk about Chat GPT, look at the things it can and can't do, and then evaluate BARD, evaluate Sydney, evaluate all these other kind of models. But remember, in 6 months, the landscape is going to change. So as the data scientists in your respective agencies, you should absolutely be keeping that in mind and letting people know, especially the executive level, kind of how the landscape is changing. I think that's our job as data scientists. The next is this issue of alignment. There's a lot of work into research for bias and ethics for using models responsibly. But there's this larger research on, do AI models work for the public good in general? And how do we align them to public good? So as they get more and more complicated, they become harder to understand how the weights work. And I think OpenAI has not really been doing a lot of great work on alignment research. Alignment is making sure that the ultimate model will reflect the cultures and the norms that we want to reflect in that. And there's been a lot of really good research that has been happening kind of on the outside in the academic community, but also in this kind of hobbyist hacker community that I want to call out. If you're interested in these sorts of things, alignment is the word that you should be looking for. And finally, Ben mentioned that we are working on a Tiger team. Then the Tiger team is supposed to guide CDC's recommendations for what we're going to be doing with large language models, including Chat GPT. We're not making the statement of this is what we're going to do. We're going to recommend certain things to senior staff. But part of the exercise was we took our team of like 17, 18 people, and we just went crazy with use cases, which is really great. We have some really fun ones that we came up with, ones that we didn't predict that would go well, that people were very clever and creative about. But we also did the same thing for harms too. Like, what are some harms using Chat GPT that could come to us? And when we started the exercise, we're like, okay, cool. Chat GPT can make fake content, or like it could create simulated content that we might think is real, and we might release that to the public. And as a public health agency, that's a big deal. Chat GPT sometimes will generate code that won't run. Also a big deal. The security risks, all these things that we had thought about, these are all internal risks. We didn't consider external risks. We didn't consider, as federal agencies, what does it mean for the public to have technologies like this that are freely accessible? And I think that, I think it's actually right in the chat right now from Matt Brown. One of the things that we identified is this deluge of comments to RFIs. We had a RFI that we expected about 700-800 comments on. We got 160,000. Were they all generated by a large language model? I don't know. But the fact that there was 3 orders of magnitude increase in that will show that there are external risks that you can't ignore. Even if you never want to use ChatGPT, the world is going to be using it. And what that means, I've seen lots of really interesting things in the chat. And I apologize, I look like I'm Ben Rogers, maybe on the screen and in chat, because I joined using his link. That was me that was answering you this whole time. I think there's a lot of interesting discussions about the risks we need to assume as being the recipients of ChatGPT and other large language models. What this means for us, public comments, I think, is a really huge one. And also the ability to, somebody had mentioned this in the chat, to create fake news articles, to create fake references, to create fake things that will fill up the editing pipeline, the submission pipeline. These are boring but very real concerns that I think we should have. So I will love to share with you this Tiger Team document once we finish it, if we have the clearance to do so. I think a lot of you on this call are really interested in what it means for us and what it can do. And I think these conversations are really necessary. Like I see the chat happening. I think we need to keep talking with each other and making sure that like we don't have guidance from the top. So we, as the operational divisions, need to figure out good things to do as guidance is being developed from high up. So these conversations are great. I encourage you having them. I encourage meeting one-on-one. We are always happy to meet to talk about this. But I'll pause now because I think there's a lot of discussion. Yeah, the comments are crazy. There's like 160,000 public comments. The exact number doesn't matter. Because it went from something that was on order of 1,000 to something that's on the order of 100,000, which meant that the systems that we had in place have completely changed. So I will pause now and I guess open it up for questions.
Yeah, thank you both. I guess we could let people, well, why don't we have folks raise their hand first, so we don't have people talking over each other. So if you have a question, go ahead and raise your hand. I'll just have a comment on the last thing you said, Travis. It seems like that's another sort of denial of service attack or something. Right?
It is. It's a denial of service on, I guess, the humans themselves that have to do the review process. Yeah. There are some comments in the chat that I think we can get to. Paul Moran says, wait, ChatGPT produces code that runs really, 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 really well. Fantastically well. And I think a way to think about this is ChatGPT, like all AI models, are really good at interpolating. So if you're asking it to produce code that somewhere somebody has written, it will probably be able to reproduce that or synthesize it in a way that you're asking it, write me code that could do X like Y. If you ask it to do something totally novel and something that's never been done, like solve the Riemann hypothesis for me, it will try to make something up, but you're extrapolating outside of the knowledge that it kind of knows. But yeah, it's really, really good at writing code in all languages. You can give it code that you wrote, ask it to translate it to a different language, and it's almost entirely correct. There's some comments of people saying that you could use it to write zero-day vulnerabilities to hack into systems. I think that comment is overblown because, again, it's interpolating zero-day exploits, right? These things would be available to Google anyways. It's not going to do anything particularly novel or particularly creative. That's outside of the scope. If you're finding it able to do it, you would have been able to find it through, say, Google searching anyways. Yes, James, has there been any discussions on how to guide the use of large language models internally with the NIST AI framework? If you guys haven't seen this, NIST put out this framework. It's and maybe somebody could put it in the chat. It's the NIST AI RMF, Risk Management Framework. It is this dense document describing all of the harms and risks that you might have when using AI, from inception of an AI model to development to release to deployment to eventual sunsetting. You should look at it and you should try to incorporate that into your agency. Within NCHS, we have adopted a small piece of it for model releases. So like we release data. So like, what does it mean to release an AI model? Ben mentioned SANS, this model we released. We basically use the framework to discuss, model cards and how they could work into data releases for us. The NIST framework does cover a lot of deployment of AI models, and Chat GPT certainly would fall under some of those, but if you read through them, a lot of them are obvious that like you need to consider how the outputs would be used, and it's very contextually based, right? I don't think we could say as a agency, as CDC, yeah, ChatGPT is good or bad. I think it's good or bad for particular use cases, for programming, maybe for writing PDs, for HR, for, rewriting scientific communication so it's more accessible. These all have different risk profiles, and I think they need to be evaluated independently. Thanks, Mike, for putting that in the chat. Yeah, Peter mentions ChatGPT fails on 4-digit multiplication, and I think that's a really good point in that these models don't inherently understand what they're doing. They're just really good at synthesizing content and interpolating. And when you ask a very specific math question that requires a certain level of computation, large language models are still going to struggle with that. It's amazing that it can pass the LSAT as well as it could, but that means the language, that information is interpolated from all the other pieces, the semantic content that it's read and learned. When you ask it to multiply numbers it's never seen before, it's trying to interpret those things as words, and sometimes it does okay, but generally it's still failing. Okay, I wasn't able to keep up with the chat. John asks, what are the risks from more autonomous large language models when code interacts with the API to generate more code or interact with the command line, which then it runs and then feeds back to the large language model to decide the next thing to do? Auto GPT or Agent GPT, I've seen one that does this. I think those are really cool projects. I think those are akin to giving your junior developer who's had 1 week on the job sudo access or admin access. Like you would do that. Autonomous AI broadly is really well defined in the NIST framework. So I think my answer would be like, that's how you need to approach these sorts of things. However, I think the more interesting thing for Chat GPT is the use case that Duolingo has. So Duolingo is an app where you can learn a new language. You can learn French, you can learn Chinese, you can learn Spanish and learn English. And it talks to you, and it talks to you like with predefined phrases so you could learn the language. Cool, it's been standard. They've incorporated Chat GPT so you can have a conversation on a really basic level in another language, which seems silly, right? It's like you have this super powerful AI and you're using it to talk about getting a baguette. But it's amazing for learning languages. It's like this perfect use case. But getting to the autonomous large language model question is that, is it safe for you to release a chatbot to your users, right? We talked about the harms, we talked about the risks, we talked about the biases, we talked about how sometimes it can get off the rails. That's a risk for Duolingo, with people that don't understand how these models work. If it says something harmful to them, and now you translate Duolingo to, say, an agency like CDC, where the words that we say from our chatbot could really matter and could cause significant harm versus a chatbot. So I don't think anybody's taking LLMs in a serious production way and letting them have full run on the code. I think it's a fun exercise to consider that. But I think the more realistic scenario is a chatbot scenario that you've incorporated into your flow.
Hey, Travis.
Mhm.
I have a question. I guess do you guys have to jump off right at 4?
No, I'm good.
Okay. And I think maybe Ben alluded to this, but if you ask ChatGPT a question, and then, I don't know, say 5 minutes later, you ask it the exact same question, will it give you the same text?
No, and this is a really fun thing. I think Ben's slide with Sancho got a little bit to this, but the way it works, if you were to say, Chat GPT, give me one word to complete this phrase, the cat in the blank, right? There's a lot of words that can go in there. One of them is hat, cat in the hat. That's a very famous kids book. You could say the cat in the box. You could say the cat in the door. You probably couldn't say the cat in the space. I mean, you could, but that's less likely. And you can't say the cat in the. Syntactually, that doesn't even make any sense, right? So you could imagine, like as a statistician, a probability distribution of all the words to choose. And that's literally how ChatGPT works. It's how all large language models work. They try to predict something, in this case, the next word or the missing word, and they generate a probability distribution. And then they choose a word based off this, based off the logics that are coming out of it. If you've seen some of these things, if you dive into it, they have a temperature, which is really kind of fun. And this is for all my physics stat mech nerds that are out there. If you turn the temperature really high up, what happens is all the words that have low probabilities of happening become more likely. Things become more chaotic and more likely. You're increasing the probability of these low frequency words in the cat in the hat or the cat in the story. If you turn down the temperature, you make only the things that were likely to come up before really likely. And so if you turn the temperature all the way down to 0, then you actually make ChatGPT 100% reproducible. But it's also really boring. It will say the most boring thing because it will literally tell you the most predictable next word. It's a great question.
Yeah, that's interesting because I've not used ChatGPT. I haven't even looked at it. So So that's pretty interesting. So yeah, I guess you could, by using that temperature, really adjust the, I don't know the right word, but sort of like how important the probabilities are, or interesting.
Yeah,
Wow.
and thank you, chat, for I wasn't watching when I did this. It looks like everybody said exactly what I was talking about. On
So
the
that was reproducible then.
yeah, in the version that you can play with when you are on the computer, you can't change the temperature. If you use the API, you can change the temperature between 0 and 2. And I don't know if you guys have ever tried playing with temperature 2. It's wild. It's just a mess of random strings. It's really fun to see like the unhinged output coming out of it. But if you do set it to 0, it will reproduce what you're saying. And that is the most boring thing that could come out of it.
That is super interesting. Okay, so now you're inspiring me to maybe play with it a little bit.
I guess that's the point of this talk, is to think about large language models and how they can help you within your agency.
Yeah. Great. Okay, any other questions in the chat, or anybody want to come off of mute and ask it live? Certainly a new world, isn't it? Okay, well, I guess we will wrap it up then. And I would just like to thank our two speakers, Ben and Travis. This was fantastic. I learned a lot about Chat GPT. It's been a little bit of a mystery for me. And of course, people have been talking about it a lot these past many months. So it's really great to learn more about it. And we will, thanks to Travis and Ben, we will post the recording. I'm not quite sure where it goes yet because we're still figuring that all out. And you said we could share the slides too, right?
Yeah, I have no problem with that.
Okay, great. So if you would like a copy of the slides, you could send an email to me. It's wendy.l.martinez@census.gov. And I'll send it to you. But I guess I should get them first from Ben and Travis.
I'll send it to you right after this meeting, Wendy.
Great, sounds perfect. Okay, well, thank you again. And here's some applause. Sorry, we can't do it in person, but oh, there you got some Zoom applause there. Great. All right.
Thank you, everyone.
Yep, thank you. This was fantastic. We really appreciate it.
And thanks to the chat.
Yeah. All
Thanks,
right.
everyone.
Take care.
Bye-bye.
Thank you both. Hi, Sheila. I hope I said it okay. So
Yes, thank you so much. Thank you.
You're welcome. And actually, my typing is so bad. So it's wendy.l.martinez@census.gov.
Lovely. Thank you again.
Oh, you're very welcome. Thanks for joining us.
Bye-bye.
All right, bye.